I am, despite the dark hour here, I am sitting in California on the west coast of the United States. It is 5:12 a.m. I did get up and shower before I joined you all, so I am, though, delighted to be here. And you know, I used to travel a lot pre-pandemic, and it wasn't unusual for me to get out of bed at 4 a.m. to catch an airplane. So I just kind of mentally think of it that way. Like, I got up this morning at 4 a.m. to catch an airplane to see y'all, and it was a pretty quick flight. So I am so thrilled to be doing the opening keynote for this. I will introduce myself a little bit more in just a moment. In fact, I'll move to that slide now. So let's see if I can advance slides properly. There we go. And for those of you who don't know me, I'll tell you a little bit more about myself. This is the first GitOps Con, and for me, GitOps is about a 15-month, 16-month journey right now. So I joined Weaveworks at the beginning of 2020, first working day of January. I've been in the industry a long time. I've been doing this stuff for about 30 years, and I've always been a developer. And you'll see why this is relevant as we go through the program. I'm going to be talking a lot about the developer or the application team and what enables them to do their job quickly.
Sonia,
yes,
we cannot see your slides. I'm sorry.
You cannot. That's because I have not shared my slides. Thank you. Maybe it is just a touch too early.
I had coffee pre-staged for me this morning, so there we go.
There we go. Now I bet you can see him because I can see it in the Hopin platform. Thank you.
No problem.
So where I was I have been a developer my whole career. And prior to joining Weaveworks at the beginning of 2020, I spent the previous 7 or 8 years at Pivotal, where I worked on developer platforms. First on Cloud Foundry, was part of the team that brought Cloud Foundry to market. And then in the last 2 or 3 years, spent quite a bit of time with Kubernetes. Prior to that, I spent a lot of time in web architectures. But you can see there that I've been doing Cloud Native for a while. And if you remember, the title of this talk is Cloud Native Ops Edition. And I'll explain that as we go along in just a moment. But I have been doing Kubernetes for quite some time, more than 5 years or somewhere around there, which doesn't make me the longest veteran, but it doesn't make me a newbie either. And if you'll permit me the shameless self-promotion, but it is relevant here, is that I'm also the author of this book, Cloud Native Patterns. Now that book did Cloud Native for developers, and it really talked about Cloud Native patterns for software architecture for those developers. And you'll see again why this is important in just a moment. Now, that's the whole point, is Cloud Native. And on my title slide, I said I've been doing Cloud Native for almost 10 years. But I will admit that the term Cloud Native didn't really exist 10 years ago. The term that existed 10 years ago was this one, microservices. Or maybe not quite 10 years ago, but we were probably starting to talk about it. Now, the reason that I bring up microservices is because it's probably the more common phrase, or certainly the phrase that we've been using for longer for Cloud Native. But the interesting thing about microservices is that we had a few attempts at modernizing software architectures before that. Who remembers SOA? Service-oriented architectures. Remember? We put SOA interfaces on top of these monoliths or on top of different backends. And then I spent a lot of time studying and working with the W3C and others around REST APIs. We also did that. And then well before microservices, the term became popular, we had domain-driven design. So we were starting to hint at that. But the reason that I'm belaboring this is that those earlier attempts at service-oriented architectures or RESTful APIs didn't cause a major change. They were attempts and they gave us kind of incremental improvement, but there wasn't like a hard right. There wasn't an inflection point, I would suggest, with service-oriented architectures or RESTful APIs. But something different happened when we started doing microservices, and I'll talk more about that as we go through. Now, as we started to build those microservices, the first signs that there was an inflection point happened when we started seeing articles like this. Microservices, not a free lunch. We didn't just start to componentize things and keep doing things the way that we've always been doing things. We started seeing articles like this and conversations that said, well, yeah, there's all these advantages of microservices that I'm not going to go over. A few of them were listed on the previous slide. But then we started seeing people acknowledging that, okay, as I break things up into smaller pieces, with that come new problems. All of a sudden, I had highly distributed architectures and I needed to start worrying about additional patterns. So if I'm highly distributed, I can't just do a function call that's in process and know that it's going to make that function call. I had to start worrying about things like, well, if I make a call over the network and I don't hear back, what do I do about that? Do I just give up and go home or retry? Or do I start using common patterns like caching, not just for performance, but for resilience? And if I'm going to do a retry, then I need to start thinking about things like idempotence. So we started to see this whole new world this whole new conversation start to happen around these microservices. And I'm going to suggest that it was that change that made this different from SOA. It made it different from just RESTful APIs because we actually started to do things differently. And I'm going to suggest to you right here and now that GitOps represents that differently for cloud native operations. And I'll explain why as I go along. Now, he's very wise and can often be a good predictor of where we're going right around the same time that previous article that I showed you, and all the links are on there, which was published in 2014. Right around that same time, Martin Fowler writes a great blog post. And the great blog post was called Microservices Prerequisites, and you can see the link there. And this is one of the graphics from it, and it's super great. It says you have to be this tall to ride the ride. Now, he wasn't talking about software architecture patterns like retries and idempotence and circuit breakers and some of those other patterns. He started talking about these things. These are the headline subsections that were in the document. Rapid provisioning, basic monitoring, rapid application deployment. He started talking about things that were hinting at operations. Now, he was talking about those things earlier on in the software development lifecycle, but he was talking about things that started to hint at operations. Yet, despite the fact that he posted this in 2014, I'm going to suggest that as an industry, we matured software architecture patterns. And we also, by the way, matured some of the processes, some of these rapid provisioning and so on. We did that, but for earlier in the software development lifecycle. So for example, we started to mature things around CI and test-driven automation and test automation. We started talking about code coverage, and you started to see badges of code coverage on open source projects. And those things were really clearly understood that it helped us close those feedback cycles, make those feedback cycles shorter and shorter and shorter. So there was a lot that we needed to do in the early parts of the software development lifecycle. but I'm going to suggest that it's been lagging a bit on the operations side. Now, this is one of my favorite photos. This is a photo that I took at the DevOps Enterprise Summit, which is, if you haven't heard of it, a really great conference. Virtual is coming up in a couple of weeks. I sit on the programming committee. This is the conference that is put on by Gene Kim. So if you don't know who Gene Kim is, you might know him by being co-author of the Phoenix Project, more recently the Unicorn Project, also Accelerate, which is the book that kind of shows you the background behind the State of the DevOps report. And this person that's speaking there is Jonathan Smart. At the time, he was at Barclays Bank. He's also a very significant part of the DevOps enterprise community. And what I love so much, and I won't explain the entire slide, he did this slide as a build, and he's super funny. It was really fun. Is that you'll notice there that where it says we're so freaking agile, yay, that's pointing to dev. That's pointing to all the work that we've done in that development space. The things that I just mentioned, CI, test-driven automation, test automation, all of those things. Now he's calling out that while we're super fast and we can cycle quickly on the dev side, there's all these things that precede development that are slow. And you can see he's annotated them with annual, quarterly, monthly. But if you look to the right, this is the part that I'm getting to. You can see that it says waiting for integration, or waiting for acceptance, or waiting for release. So despite the fact that we've sped up the development cycle, we are slow getting things all the way out to operations. And that's where GitOps starts to answer the question. And so let's move on. What is GitOps then? Well, the first thing that I'll tell you is that GitOps takes cloud native all the way to operations. So all of that cloud native stuff that we did with the architectural patterns and then the parts that were early on in the software development lifecycle, it extends it all the way out to that production deploy. Now, before I go into the details of what is GitOps, let me give you a little bit of an idea of where we're going. Now, I'm going to explain the basics of GitOps. Now, there are going to be some basics of GitOps here that represent the difference between the SOA REST, which really didn't change much, and the, oh, now we're starting to tease out what are the things that we need to do fundamentally differently. Those are the things that I'm going to highlight in GitOps, is that those things that are fundamentally different that are going to change, because some of these things are going to sound familiar, but they're different. And I'm going to be emphasizing why they're different as we go along. So I do want to give you an idea of what those things are that are different, but I'm not going to ask you to just trust me. After I explain what those things that are different, I am going to go through an explanation of why they're important. So I'm not going to just talk about the what, but I'm going to justify why these are important. Okay, so let's start out with what is GitOps. Well, I've been saying all along, this is about production. This is about getting things running in your runtime environment. So let's start there. That's really where I want to go, is I want to get things deployed in my runtime environment. Now, you'll notice the little asterisk there. I, of course, this is KubeCon, am showing Kubernetes as the runtime environment. What I'm talking about here with GitOps is not constrained to Kubernetes. These concepts apply elsewhere. Now, it turns out that Kubernetes has some things that other runtime environments may not. So it's a really great place to start with GitOps, because some of those things are required, and you can actually see a hint of it when you see this actual state. But I'll talk more about that in just a moment. Now, I've also been talking about operations as we go along. So who's going to be doing operations? Well, we've got humans that are responsible for operating some software in production. Now, as you can imagine, there's a whole bunch of white space there. I'm going to fill that white space. So the first place that I'm going to fill that white space is with Git. Now, it's in the name. Now, I won't go into the details here, but Git isn't the only thing, but I'll talk a little bit more about what I call Git semantics later on. But we're going to use Git, and we're going to use Git to store the artifacts that are required for me to be able to do the operations. And there is an interface that those humans will use into Git. Those interfaces are equally important. Git acts as a store, but it also acts as an interface. And I'm going to say something, and I'm going to say it a couple of times because it's really super important here. It's not the interface to Git anymore. It is the interface to operations. So it's kind of this transitive thing. It's the interface to operations. It's not that I'm doing operations somewhere else and I'm doing stuff in Git. It's not that I'm just storing my infrastructure as code scripts and then have to run those somewhere else to actually do the operations. Git becomes the interface for operations. When I do something in Git, it has an effect on operations. So instead of sitting at some VI admin, a VI admin sitting at the vSphere console or sitting at Amazon console to execute operational activities, this now becomes the interface for operations. That's pretty significant. Okay, so then let's go back under the covers. What happens when I do operation in Git? I'm doing something in Git. What happens? Well, of course, there's some kind of automation that happens so that the things that I'm doing in Git are reflected in the runtime environment. Now, here's the second thing that's really important about Git, is that that automation is convergent. Now, what do I mean by that? There's two other phrases or two other pairs of words on this slide that get to what I mean by that convergent. I already called one of them out, which is actual state. Kubernetes operates on this principles of actual state and desired state. And it says, we are going to constantly, Kubernetes, container orchestration. The first use case of Kubernetes was all about container orchestration, running your container images, orchestrating those, scheduling those, keeping them running. It says, I'm going to look at the actual state of the containers running in my environment. I'm going to compare it to the desired state. Now, in Kubernetes, the desired state is generally an etcd. That's what we're going to talk about, is how to draw the desired state between etcd and Git. And I'm going to constantly be comparing those, and I'm going to bring them in alignment. That convergence pattern, again, is like the difference between SOA and REST and doing cloud native in a real way, about thinking about things like retries and idempotence. That is the secret sauce. That's the thing that's making the difference, is that convergence. So the convergent stuff is really important. Now, there's one more element on this slide, and you'll notice that the arrow goes back to the left-hand side as well. So convergent doesn't just mean left to right. It might, in fact, mean right to left. It might mean that there is some kind of automation that's happening in the runtime system that is doing legitimate things. And I'll give you a concrete example of that later in the talk, that is doing legitimate things that then need to be reflected back into the Git repository. Because not only is the Git repository, not only is Git the interface for operations, it now becomes the source of truth. It is the desired state. So and we're constantly bringing these things into alignment, if something happens in the runtime environment that should be part of the desired state, we need to ensure that that is captured as well. So what you see here in this slide is a whole bunch of convergent loops. And in GitOps, there's convergent loops around continuous delivery. But remember, I've been saying that it takes it all the way to operations. There's also convergent loops that get you running in your runtime system. And we'll talk more about that in a moment. Okay, so that's GitOps. But that's not nearly as interesting as it is until we start to ask this question. Okay, great, GitOps, but really, what are you trying to do? Why GitOps? What's the problem that it's solving? And what it really comes down to is we're trying to get better at doing software. We just want to do software better. We want to cut down our cycle times. We want to deliver value to the customer more quickly. We want to deliver value to the customer more rapidly from idea to production. Why let it stew in our minds for months and months and months? We want to get that value out to the customer. When there's a problem, we want to recover our systems quickly. So we just want to get better at doing software because software really powers everything these days. Well, for those of you who have not been introduced to this yet, I'm delighted to introduce to you the State of the DevOps report. This is the work that was done by DORA, which is the DevOps Research Assessment Organization. It was originally an independent venture that was founded by Nicole Forsgren, Jez Humble, and yes, Jez Humble of Continuous Delivery, and Gene Kim, who I just mentioned earlier. And they did some work over a number of years. DORA was eventually purchased by Google. But what I'm showing you here is a chart from the most DevOps report from DORA. There's another State of the DevOps report from Puppet Labs, but this is the one that's from DORA, from the DevOps Research Assessment. And they did some really great work that correlated specific IT behaviors with business performance. And business performance was measured on things like, are you gaining market share? Are you profitable? Those are really good markers. Do you have high net promoter scores? Do your customers really love you? Those were markers from elite performing organizations all the way down to low performing organizations. The ones that are losing market share, losing money, have horrible net promoter scores and those types of things. And they came up with 4 metrics that really correlated beautifully across these different categories. What it comes down to is that the most elite performers deploy the most frequent, have the shortest time of lead for changes. That is, I've got something that's ready to be deployed into production. And how long does it take from the time that it's ready to go into production to the time that it gets deployed? So you can see that the elite performers, less than 1 day. I've got something ready to go to production. It goes there right away. The low performers, between 1 and 6 months. From the time it's code complete to the time that customers can get value from it. 6 months, that's a long time. And those things, notice that those things are highlighted in green. Those are kind of all about the software itself. It's all about the ideas that we're building into the software. So arguably, these are the things that are the first class concerns of the developer. And then the things that are in the lower part, in the blue, start to get around resilience characteristics. So when you have a problem, then how long does it take for you to recover your system? So the mean time for recovery, for example, you can see that the elite performers, less than 1 hour, the low performers, 1 week to 1 month. When I have an outage, it takes me a month to recover? Seriously? If you're the pizza ordering web app on Super Bowl Sunday, that isn't you're gonna get fired. Change failure rate, which is when I'm making a change in production, how often do I have a failure? We're reducing that as well. And you can see remarkable differences between the elite and the low performers. So remember, the whole goal here is to get better at doing software. So I'm going to show you now how GitOps supports that agenda. Supports the agenda of being better at doing software by improving the numbers here, getting you from the low up into the elite category. Now, I'm going to focus first on the developer ones. So let's start with that developer. What we want to do is we want to enable that application team, the DevOps team. So I am using this idea of the application team isn't throwing things over the wall to somebody else. There's an application team that's made up of developers and people who are maybe developers and also have operations mojo, not necessarily infrastructure operations mojo, but operations mojo. So they're going to be operating those applications in production, and we want to help them release more frequently, reduce lead time, and just generally be able to operate their applications. So what's one of the first things that we can do to help those developers or those application teams be more efficient? Well, how about we allow them to use familiar tooling? And what am I talking about here? Well, pretty much all developers and application teams are familiar with Git. So they spend their time in Git. They might spend their time in Git through their IDE, but they're used to this Git interface. They're used to being able to, for example, see a threaded discussion around something. They're used to being able to attach tags to things and have automation happen. So when they tag something, it kicks off something in the CI process. Or it might just be the very check-in, the fact that you've just pushed something into the upstream repository that causes that automation to happen. So that's the first thing. And this is kind of table stakes. And often people think that, well, oh yeah, it's all about using Git. It's about using familiar tools. Done. But I have 20 minutes left in this session. So there's more to it than that. The second thing that is really great for the application team is self-service. Enable them to do things. Don't have them write tickets. Don't have them finish code, create a container image, and then say, all right, operations team, you can go ahead and deploy it now, and here's my ticket for that. Let them do that themselves. What I'm talking about here is not self-service infrastructure. I'm talking about self-service operations. Let them do the operations themselves. But I hear a lot of you saying, whoa, wait a minute. In order to do self-service, there's my self-service. Did I go the wrong way? I think I went the wrong way. So self-service, in order to do self-service, there's another party that has something to say for that. And that party is the group of individuals that are responsible for things like security, compliance, resilience, cost management. And what we talk about, this group is increasingly called the platform team, because we know that the way that we can enable this behavior is by introducing a platform. Platforms are essential. So when we have a platform, then we have a surface area with which this set of folks can do their work. Now, what are the things that they care about? I already mentioned some of them there, but I'm going to call out two in particular, and that is security and compliance. And I'm going to show you how GitOps supports that. And I'm going to talk about resilience and show you how GitOps supports that. So let's talk about security and compliance first. Now, here's a way that we've done some automation in the past. I'm going to assert that this is the SOA REST equivalent of the kind of modern day operations. It says, all right, I've got this CI stuff that's happening. And then I'm just going to tack onto the end of that a CD process that is kind of the last step in CI. And that CD process is now going to send things out to all of these different target environments. It's going to be responsible for sending things to dev, sending things to staging, sending things to prod. And that's fine. And sorry, I'm kind of underselling that a little bit. It's extremely valuable. We've seen a lot of value in operationalizing the CD process. There's great tools out there like Spinnaker that are helping you organize things across these different development environments and are helping you build the workflows that go across these different environments. But the reason that I say meh is that there's a security problem on this slide. The security problem on this slide is that when we have a centralized system that's doing continuous delivery, that centralized system has to have keys to all of those different environments on the outside. So there is a security problem here in that if that system is compromised, and we've seen things like from SolarWinds recently, that the software supply chain can be compromised. So if my CD system is compromised, then all of my downstream runtime systems are compromised. So one of the things that GitOps supports is it supports this pull model. So how does it support this pull model? Remember I talked about convergent systems and I showed you the cycles? What we have is in each one of these target environments, we have a reconciler. We have a reconciler that is saying, you know what? I'm not going to wait for you to push things out to me because I want to be responsible for my own security and my own convergence. I am going to take a look at the Git repository that is holding those things. So that is, I'm going to pull. And with that, your platform teams are going to be much happier from a security perspective. Okay? So that's one of the first things. Security, GitOps has a direct impact on security because of the way that we do continuous delivery. Now, I talked about security and compliance. So from a compliance perspective, I'm coming back to Git here. And what I want to show you here is the Git log. The great thing is that when Git becomes the interface for operations, then what we see is every single thing that a human has done, or even the things that have been automated. Remember the feedback loop from the runtime environment. Every single one of those things has been recorded in a log. And that's what we see here. Now this, I'm going to bring this screenshot back for a different reason in just a moment. But here you can see that there is my audit log. So your auditors are going to be really happy because everything is recorded and guaranteed to be recorded. Now, the next thing that platform team that I want to focus on is I want to focus on resilience. They're also very, very concerned with keeping the systems up and running. So in the past, this is where your change control, your head of change control would be sitting there. And coming back to this slide, the resilience is really the blue boxes at the bottom, but I'm going to take them one at a time. Let's talk about time to restore first. So here we go back to, I promised to come back to this Git view again. This is where Git semantics come in. I said earlier that it's not required to be Git, but Git has a number of characteristics that are really valuable. If you can achieve those Git semantics using something other than Git, or using a combination of Git and another store, i.e. an image repository, i.e. a secrets store, that combination of Git together with it in another external store can work extremely well as well. Now, how does Git semantics support this metric, mean time to recovery? So here's the scenario. We have an outage. How long does it take for us to recover from that outage? So what are the important Git semantics that provide that? Well, there's a couple of things. The first thing is that everything is versioned. Versioning is built into Git. What is the version? You notice there I have an annotation that's pointing to the Git SHA. This is what I mean by versioning is baked in. If you have a versioning system, and by the way, your image repository generally does not have a version system baked into it, you have to apply the version number yourself. You have to say, this is version 1. What that means is that you can, in fact, change your image and still call it version 1, but it's not really the same version. So am I using version 1, the real one, the original one, or am I using version 1 that I just bashed on top? Git doesn't even allow you to make that change, that choice. It has versioning baked in. If you go in and you change just some white space, you're going to get a different Git SHA, even though the code from a semantics perspective is the same. So versioning is baked in. By the way, I can't help but tell you that one of the best practices that we see in GitOps, and you'll probably see some of this in the later talks today, is to use the SHA as a part of what you're using to version your container images when you store them in the container image registry. So that versioning semantic is important. It's also important that it be immutable. Now, of course, we all know that we can rewrite Git histories. Don't do that. Set up your environment so that it is immutable. I'm not suggesting that early on in the software development lifecycle that you aren't going to squash commits and things like that, but don't allow that type of thing for your config repository. You want to have immutability. And then I just talked about this recently, and somebody said, "Oh, I didn't know that. This was just a couple of weeks ago." That one of the cool things about Git is that every single node in the Git history has a complete representation of the system. It's not storing diffs. Now, why is all of this valuable? Well, this is valuable so that if I have a crash, or let's say I'm running for some reason, I'm only running in one region, and that region goes down, and I quickly want to stand up my system in another region, I have a complete representation of that. I'm guaranteed to be able to identify which version I want to run because I know what version I was running. It's been immutable, and I'm just going to point it to a different region, and boom, the whole GitOps process is going to stand it up for me. So that is really important. Now, the other thing that's important, though, in order for that scenario that I just painted to work, is that you need to make sure that you haven't had any drift. If my runtime environment in the first region had changed from what was in the Git repository, then when I point to a different region and try to get my GitOps process to stand it back up, I might not get what I had before because there was some drift. There was some change that happened in the runtime system that didn't get reflected back into the Git repository. And that's an important value from GitOps, is that reconcilers constantly checking that actual state and desired state all the way back to the Git repository. And it's saying either I'm going to revert back to what's in the Git repository, or there's going to have to be some automation that ensures that if some change happened in the runtime system, that I can go back and, oh, sorry, there's a couple of little animations in there. So if I do a kubectl apply, I'm going to revert that back. Okay, so I'm coming to the end of this part, and I want to take just a few minutes at the end to kind of reemphasize some of the things that Chris and Scott said about the GitOps working group. But let's look at that last thing, change failure rate. So one of the most common, probably the most common reasons for failures, it is still that I'm making some intentional change to a running system. And so how do we reduce that change failure rate? Well, there's two things that I want to talk about. Yep, I'm coming back to Git. So of course, this is a familiar tool for the application team. So the application team is doing this. What Git does and has done so successfully earlier on in the software development lifecycle is it has been a huge enabler of code reviews, right? So we don't have the ceremony of code reviews anymore. It's ongoing. It happens as a part of the development flow. And you get lots of eyeballs and you use all sorts of tools as a part of that interface. So now that you're storing your configuration, you can implement an approval process directly in Git. And having lots of eyeballs and lots of maturity in that approval process is going to reduce your change failure rate. The other thing is this. So what we remember here, we had pull. We were pulling from the Git repository. Well, let's look at that in a little bit more detail. And what I'm getting at here, just so you know, sorry, I didn't title this slide particularly well, is I'm heading toward the direction of progressive delivery. So this simple picture, let's drill into the details just a little bit. What's really happening there, when you're using something like Flux or Argo CD, is you're pulling from the repository. So you've got some reconciler that's constantly pulling from the Git repository. And it's not pulling it all the way to the running system. It's pulling it into etcd, so inside of Kubernetes. Then there's another reconciler, which is a reconciler that's built into Kubernetes, the deployment or the replica set, that actually gets things running in production. Well, what if you want different behavior? What if you want to do progressive delivery in a very careful way? You want to do a canary deployment, or you want to do a blue-green deployment, or you want to do some kind of A/B testing or some type of a deployment there. Well, you can introduce your own reconciler that does that progressive delivery. That's another open source project that's available out there called Flagger. It's a part of the CNCF. So you can link together these reconcilers to get this special behavior. So going back to this picture from earlier, remember that GitOps is not just the continuous delivery reconciler, but I can also put reconcilers in there like Flagger, leverage reconcilers like that built into Kubernetes, and linking those things together, that's really where the magic comes in. So to sum all of that up, to look back across this entire table, I want to remind you to achieve, again, we want to get better at software. To achieve that, we want to allow developer teams to use familiar tools, and we also want to enable them to self-service their operations. How do they do that? Well, they do that. The pull model is a huge enabler from a security perspective, but then we're also leveraging the version immutable store, the fact that it has a complete representation in there, the fact that we have drift detection and remediation, that's part of GitOps as well, that I can do configuration reviews in Git, and I can do progressive delivery. These are some of the enablers. This is how GitOps enables us to do software better. That's the real punchline. All right, with that, I am going to just very briefly give you a little bit more about the GitOps Working Group. The GitOps Working Group, of course, is the group that is giving you this event today. So to give you just a little bit of context, the GitOps Working Group is a part of the CNCF. It lives under the umbrella of the Special Interest Group for Application Delivery, which is a special interest group that sits under the Cloud Native Computing Foundation. Now, there's a whole backlog of work that's happening there, and I'm going to talk about the GitOps principles in just a moment. But we're putting on this event right now. We've got the GitOps principles, which I'll talk about. We're working on a website. We're working on samples or supporting samples like this Potato Head project. In the future, we have ideas around having a GitOps landscape. So a smaller thing than the cloud native landscape, but it's specifically around GitOps. We're also looking at doing certifications and those types of things. Now, those things like the landscape certifications and the principles, they're going to live under an umbrella of a sandbox project called Open GitOps. So Open GitOps is going to be the set of things that make up the practice of GitOps. And the GitOps working group is responsible for creating and caring for that. Now, the first of those artifacts are these GitOps principles. So I'm just going to give you a quick overview, and I invite you to join us in asynchronously or synchronously. We have monthly meetings to continue to discuss these things. You can find these GitOps principles in a pull request in one of our Git repositories. But here's the principles, and you're going to see these things. These are the things that I've been talking about for the last 45 minutes or so. The first principle, as written in the draft document in the PR, is that the desired state is expressed declaratively. You heard me emphasize the importance of these reconciliation loops. What that means is that we need to have declarative configuration that represents the desired state so that I can compare it to the actual state. Those things need to be stored in a way that we can achieve the types of things that I described. They need to be versioned and immutable and have that version history so that I can do things like when a region goes down, I can stand my software up in a new region with no fuss. That's the importance of that principle. The third principle is all around those convergent agents, those agents that are causing this convergent. And those agents are both on the continuous delivery side. You see the Flux and Argo logos there, as well as on the runtime side. Kubernetes itself or cluster API represents a set of convergent systems that bring things into a desired state. And then finally, the fourth principle says interface for operations. These are the things, these are the ways that we're going to do operations, is controlling the desired state in a Git repository. That is the interface to operations. So in closing, GitOps is about continuous delivery and continuous operations done in just the right way. And this is the inflection point for cloud native operations. And with that, I thank you for your attention. I was thinking I might have time for questions at the end, but as usual, I kind of consumed the whole time, and I hope that was valuable. With that, I'd love to hand it back over to my hosts here, Chris and Scott. Back to you.
Scott, that's you. All right, you're muted. Sorry about that, Cornelia. We have a few questions here, if you have time.
Oh, I do.
Okay, great.
If the agenda can take it, yep.
Yeah, we can do 3 or 4 minutes of questions here. So I'll go from oldest to latest, oldest to latest. Sorry, it's our list here, everybody. So do I understand it correct? GitOps does not mandate Git in Kubernetes. Or in other words, can we assume GitOps as a framework, then attaching tools to it like Git and K8s and so forth, so on?
Yeah, so that's a great question. The first thing is that GitOps, if you notice that I closed, and the first thing that the GitOps working group is creating under the Open GitOps project is a set of principles. So the most Git is the principles. If I go back to my analogy of there was a change, an inflection point in cloud native from an applications perspective, it didn't say you have to use the Netflix suite you don't have to use Eureka for this particular pattern. You don't have to use Eureka for service discovery. It said you need to have some type of a service discovery mechanism. Can you use DNS? Yes. DNS is what Kubernetes does. Can you use Eureka? Yes, you can. But the principle of service discovery was more important than the actual tooling. Now, that said, remember that the principles require certain semantics to be applied. And those semantics exist in Git, or they require convergent loops, which is something that's available in Kubernetes. So if you're not using Git in Kubernetes, then you have to find a way to achieve those characteristics a different way. But you're absolutely right that the principles are more important. And I guarantee you that we will start to see implementations of these principles come through in other tools and technologies as well.
Awesome. Thank you for that answer. Next one. What is the recommendation here? One Git repo per microservice for your application, or one Git repo for your whole application, but it is per cluster, i.e. one for dev, QA, certification, prod, so forth, so on. What is your recommendation there?
I will keep my comments brief because I believe that we will see maybe a bit of this later on in the program. But the answer is that to a large extent, remember that one of the control points that you have through Git is that you can set up groups. You can set up permissions in Git. So that's one of the most important things that you need to consider when you're structuring your Git repositories is you need to say, well, who's allowed to do what? Is everyone allowed to edit every single microservice? Well, then maybe you can put things all in one mono repository. But if you want to partition and say, Team A is responsible for this microservice and Team B is responsible for this microservice, and for some reason you don't want to allow them to be able to operate each other's things, then you probably want to set up different repositories. Mm-hmm. Then it also ask about dev, staging, prod. Again, you need to think a little bit about, quite a bit actually, about who's got this. There's often separation of duties. So your application developers in some scenarios are not allowed to do operations. So even though you have an application team that's made up of devs, there's only going to be a small set of people who can actually make the code, make the commits into a prod repository. So you might need separate repositories from your dev, staging, prod. And then there's also, we can get into the details of, well, you want to pull changes from earlier in the software development lifecycle, dev into staging, and branches can help with that. So there are some folks that like to have branches for dev and staging and UAT, and then maybe a separate repository for prod. The jury's still out on some of those things. There's still ongoing debates. And hopefully we'll see some of those best practices a little bit later today.
Yeah, there's a lot of questions in here about like the Git repo structure. So we're going to talk about that today in whole. So hold tight, folks. Like there's a lot of ways to skin this cat, for lack of a better term. Including the question of what is the recommended secrets management for GitOps, right? Like there's a lot of tools in that space, like sealed secrets or SOPs or you name it. There's Vault, the whole gamut of tooling is possible, right? Like there's no one right answer. It's the tooling that works best for your organization usually is what I recommend to people. Sealed secrets for Git, that's like kind of the expectation I feel like for sealed secrets at points. But yeah, it's one of those things where focusing on doing it the right way will hurt you institutionally, right? Like do it the way that works best for you. GitOps is a guide to kind of applying great DevOps principles in this very multi and highly distributed environment that we're in right now.
Yep.
Scott, did you want any of these other questions real quick before we need to go? And you're doing your dubstep remix again. This is not good, Scott. Anyways, muting him again.
Scott, you might want to leave and come back in.
Yeah, you might have to hit the hard reset or something, Scott. Is there a set of best practices concerning the prod to dev promotion of applications? I don't know if you have anything to say on that, Cornelia, but I don't think there is a quote best practice. I kind of hate that term best practice for lack of a better term, right? Like,
yeah. No, I think I'll hold comments on that. I think that falls into the category of hang tight. Let's go through the program and then come join us because we'd love to have some of those debates with you as well.
Exactly. All right. So we are having some technical difficulties with the next speaker. and some technical difficulties with Scott. So this is going swimmingly right now.
How about now?
That is way better. You're not giving us a new step. I appreciate
Yes, I thought it was my speakers, but apparently I had headphones in and it still happened. Did you try turning it off and on again? I did, and it worked. So
yay.
We're back. So did we want to go over one of the other questions, or are we ready to move on to the next?
We're ready to move on.